For 15 years, Jenkins was the undisputed king of continuous integration.
Many enterprises ran Jenkins servers running thousands of Groovy pipelines.
By the mid-2020s, a new paradigm gained traction: AI-assisted DevOps tooling that helps write, optimize, and self-heal pipelines with less manual toil.
This episode explores that shift with illustrative scenarios for learning, not vendor benchmarks.
In this illustrative teaching scenario, Jenkins adoption metrics are often cited as declining relative to newer approaches. Platform teams commonly report spending significant weekly hours on plugin conflicts, agent scaling, and credential rotation, while teams using AI-assisted pipeline tooling report substantially lower maintenance overhead.
Treat these as directional comparisons for learning, not verified survey results.
Jenkins was built for a world where pipelines were static and predictable. Write a Jenkins file, commit it, hope it works in production. When it breaks, and it always breaks, a human debugs Groovy at 2 a.m.
AI agents operate differently. They observe your repository, understand your deployment patterns, and generate pipelines dynamically.
When a dependency changes or a test fails, the agent adapts the pipeline in real time.
No Groovy. No plugin updates. No 3 a.m. pages.
The architecture shift is profound.
Traditional Jenkins follows a declarative model: humans define every step up front. AI DevOps agents use an observational model.
They watch your codebase, your test results, your deployment history, and your incident logs. They build a mental model of how your system should deploy. When conditions change, a new microservice, a database migration, a security patch, the agent updates the pipeline automatically. Think of it as the difference between a printed map and GPS with real-time traffic.
Consider an illustrative fintech scenario: 200 engineers and dozens of Jenkins pipelines. A platform team might spend multiple full-time equivalents keeping Jenkins alive.
In a phased migration story, teams often report higher deployment frequency, fewer failed deploys, and engineers shifting from firefighting to platform product work, but your results depend on org maturity, legacy constraints, and execution quality.
If you're thinking, we have 10 years of Jenkins investment, we can't just rip it out, you're right.
Nobody is suggesting a big bang migration.
The smart approach is shadow mode: run AI agents in parallel with Jenkins, compare outputs, build confidence.
Phase 2 is hybrid: new services use agents, legacy stays on Jenkins.
Phase 3 is full migration once you've validated parity.
Most teams were tracking complete this in 4 to 6 months with zero production incidents attributed to the migration itself.
Let's talk about the elephant in the room: Jenkins plugins. There are over 1,800 plugins in the Jenkins ecosystem. Your average enterprise uses 300 to 400 of them. 47 commonly used plugins had known CVEs in 2025 alone. Every plugin update is a compatibility roulette. AI agents don't use plugins. They use APIs, SDKs, and direct integrations. When GitHub changes their API, the agent adapts. When AWS releases a new deployment target, the agent learns it.
No plugin maintainer required.
No 6-month wait for compatibility. This shift changes what platform engineers need to know. Groovy expertise becomes less critical.
Agent orchestration, prompt engineering for DevOps contexts, and observability design become essential.
The platform engineer of 2027 isn't a Jenkins admin, they're an agent supervisor.
They define guardrails, set policies, review agent decisions, and handle the edge cases agents can't.
It's a higher leverage role.
Instead of writing pipeline code, you're designing the system that writes pipeline code.
Here's what to do this week.
First, audit how many engineer hours your team spends on Jenkins maintenance, include plugin updates, agent scaling, and pipeline debugging.
Second, pilot an AI DevOps agent on one non-critical service.
Run it in shadow mode for 30 days. Third, measure deployment frequency, mean time to recovery, and pipeline failure rate before and after. Fourth, if the numbers hold, and they will build your migration roadmap.
Start with new greenfield services. Don't wait for Jenkins to become your team's full-time job. Jenkins isn't dying because it failed. It's dying because something better arrived. AI DevOps agents represent the biggest shift in CI/CD since Jenkins itself launched in 2011. The teams that adapt in 2026 will have a compounding advantage in deployment velocity, reliability, and engineer satisfaction.
The teams that wait will spend another year maintaining groovy scripts while their competitors ship 10 times faster.
The future of DevOps is agent-driven. Start preparing today.
I'm AI DevOps Daily. See you in the next episode where we walk through a full Jenkins to Terraform modernization case study.